The title on the paper is Why You Should Not Write Your Own Framework. I submitted the abstract. I wasn't really sure what the answer was. After I submitted, I finally decided to write your own framework. And then I thought about some more. And then I wasn't sure. So I'm Christopher Stryker. I'm with Color Measurements. And let's jump in. So to start off with, our giants are female. Sadly, Kate Libby from Hackers was the biggest female influence I had in the computer science world growing up.
Why is that sad?
She's not a real person. She's a real person, it'd be great.
Right.
But I did some thinking. Hedy Lamarr was an actress in the 30s. She was largely, if not completely self-taught in the areas of science and technology. She with another gentleman invented the concept of frequency hopping in the 40s. Frequency hopping is used by the Bluetooth mechanisms. It was used in Wi-Fi for a while. They used it for torpedoes for a while. They used it for torpedoes to jam frequency to keep them from being jammed. It underlies so much of what we do. And this was invented by someone who had very little formal education in terms of science and technology. So that just really spoke to me. So what this presentation is, first of all, it's intended to be a conversation. If you just sit there and don't say anything, we're probably going to be done relatively quickly. Maybe that's good, I don't know. But anyway, it's also something to think about when starting a project. What it isn't, it is not incredibly technical. You want a single wire in this presentation, nor a single block diagram or front panel. It is not a blueprint for success or a blueprint at all. It's something to think about. I do want to acknowledge that I'm going to talk about a few different frameworks as I go along. Probably I'm going to mostly reference messaging frameworks, specifically Asher framework and DPMH. I'm not saying there's a better framework among any of them. The point is we're talking about frameworks in general. Those just happen to be the two I'm most familiar with. So if I start making references to AF and DPMH, that is why. It's not that I think there is one true answer. So what a framework isn't? Let's start there. As I was writing this, GDevCon 2 was going on, and I was having this internal debate with myself about what an architecture is and what a framework is. Because when I sat down to write the presentation, I thought to myself, oh, a framework is the architecture of your application. But as I was going through things, I finally realized that's not true. And at about the same time, Alan C. Smith had this great quote from GDevCon. Asher framework, DQMH, and other messaging frameworks are not architectures. They are messaging tools that you use to build your architecture. And this really spoke to me. So that got me thinking, and we'll get more to that later. But one thing I will note, Alan refers to them as messaging frameworks. I think that's probably the better approach. You may hear me refer to them as application frameworks, because that's the way I've traditionally thought of them. But if you think of a messaging framework as an application framework, you get an implicit architecture in many cases. And that architecture is just how you happen to throw things together with the messaging framework. You haven't usually thought through the actual architecture. So if you think of it as a messaging framework as a tool, then you end up with a better architecture. We'll talk about that in a little bit. So, it's not an framework isn't an architecture. It's also not a design pattern, a library, or a toolkit. We've talked about architectures being built from frameworks. Well, similarly, a framework is built from libraries, toolkits, and design patterns. So what is a framework actually? Let's look at the things that define what a framework is. First off, we have the Hollywood principle. Don't call us, we'll call you. This is a phrase originally written by Richard E. Sweet in a paper called The Mesa Programming Environment. This was around 1985. So the roots of extensible frameworks are way back. In more recent times, Martin Fowler has termed an inversion of control. It's really the same concept, but what it's saying is your framework, well, the framework you are using is not something you call directly. In most cases, your extensions are called by the framework, and the framework does all the work for you. All you have to do is the specific logic needed for your application and architecture. So it's that inversion of control that really defines the framework. Also from this same paper about the basic programming environment, there was this, I couldn't resist this quote. It's not directly applicable. But the gist of it is, Mesa was a project that had been going around in a research organization. And then it went to the development organization. And the emphasis is mine, but while some of the same designers worked on it both places, there was now a definite engineering flavor to the effort. Several times the 90% solution was implemented. That quote really stuck with me because I consider myself a software engineer. And engineer shouldn't mean the 90% solution. So that's just a little non-sequitur stuff with this paper that hopefully you can take away and prove wrong. I said extensibility defines a framework. Here's one example of how a framework could be extensible. This is using LabVIEW classes. That's not a requirement. There are other ways of extending a framework. I personally think in classes. It's kind of disturbing how class-based I am. So I use classes. But that's not to say there aren't a bunch of other ways to extend the framework. The key here is you notice it's not a flat inherent hierarchy. There are different layers, and each of those layers extends the previous layer. We've talked about frameworks. There's also a holistic approach to frameworks. The Cocoa library, .NET, these are actually considered frameworks. These have compilers, IDEs, all of these things wrapped together into one big package that they refer to as the framework. If you wanted to take that approach, you could consider LabVIEW a framework. There's precedent. I'm not going to take that macro approach, but it's just an interesting thought process to keep kicking around. So let's look at types of LabVIEW frameworks specifically. So we have messaging frameworks, things like Active Framework, the NIQ message handler, Delaware message handler, JKI state machine objects, I believe also fall into the category of the messaging framework, although I haven't used them as much. Testing frameworks like Unit Test Framework or JKI DI Tester. Development frameworks like Loop. UI frameworks like View Controls. Communication frameworks like VCAP. These are all things that do the work for you. And that's one of the cornerstones of a framework, is it does most of the work for you and you just extend it as needed. So, why you shouldn't write your own. Let's talk about that first. Everybody in here is going to go home and have safe travels. That's a given. But not everybody does. There's the hit by a bus principle. Unfortunately, if you're hit by a bus, your framework suddenly becomes bordering on useless if you haven't done enough to document it, because nobody knows how to use it. So keep your coworkers in mind. And one anecdote I always have held with me, I have a colleague who interviewed for a job, and I asked him, what are you going to do to make yourself irreplaceable? Thought about it for a second and said, absolutely nothing. Because if I make myself irreplaceable, suddenly if something does happen to me, or as Matt likes to say, if I win the lottery, go on a great vacation, you're hosed. You can't do anything without me. So another key takeaway that's not directly in line with presentations, don't make yourself irreplaceable. It's just a bad idea for everyone involved.
Do my job security.
Rely on competence.
It's not a great job in most cases if that's your job security.
If you're worried about that, you got to.
The standing joke on that is that you can't be replaced, you can't be promoted.
Yeah, I hadn't thought about that, but yeah. I like
You can't
that.
stay right where you are because they can't replace you.
Yeah, I like that. So, pulling back in a little bit, we talked about architectures, frameworks, and design patterns and how they're all kind of interrelated.
I think you're plugs.
No, I'm not.
Oh, okay. Never mind.
1 second. Who here is familiar with the Gang of Four design patterns book? Looks something like this. Okay? This is a fairly essential book in my mind. There's a lot of important stuff in it. But how many people here have actually read it? Cover to cover. Okay, I haven't. But I did read the front matter. which was really interesting. I skimmed here and there where I needed, but the front matter was honestly the most interesting to me.
It's a tough read.
What?
It's a tough read because everything is very abstract.
It is. But in the front matter, it says it was actually based on another book. Anybody know that? The Design Patterns is not the original work. It was based on a book called A Pattern Language by Christopher Alexander, and they give credit to him for much of the underlying thought process. And in that, it was a book about architecture. This book says, hey, there are a lot of common things out there in the world, and if you look around and find all of these common things, you can string them together in different patterns, and you can make a language out of the different patterns. So it's getting a little off course, but the key takeaway from this was, this book, which is considered one of the primary books in our profession, was inspired by architecture, actual buildings. So that got me thinking. Here we have the Chrysler Building on the left and the Empire State Building on the right. Both of these were built about 1930. Both of them in the Art Deco architectural style, but they're distinctly different architectures. Every building is a unique architecture. Similarly, well, pause for a second. They are distinct architectures, but do you know what's the same between them? Anybody guess? There's one major thing that's the same between them.
They're pointy.
Sure. A little more structural, though.
They use the same materials.
Same number of floors.
They both have 70 Otis elevators. These elevators form the transportation framework of the building. They share the same framework. So, so with that said, every application that you write should have a unique architecture. If you're writing two applications with the exact same architecture, chances are you're writing the same application twice. But those applications use frameworks. Those frameworks should be immutable. You should not change the framework from one project to another, or else it's not a framework. Huge thanks. I'm sorry I neglected to mention this. Well, you guys don't care. I neglected to mention this in my last presentation. This kind of realization, I guess, came out last night on to Sergio from Conrad Technologies and Sam Patrick. So I want to give them credit because something they said kind of made this click. So, key concept, architectures are unique. Architectures are unique, frameworks are universal, is the goal. That's really hard to write a framework that does that. That's really hard. Stephen Loftus Mercer likes to say that when he wrote the priority queue used for active framework, he has not changed he's not had a single car filed against it. I think that's amazing. That was really hard to do, I'm sure. Lots of testing. Things like that pre-exist. Let's think about reinventing. So, everyone says don't reinvent the wheel. Everyone says, I had to do it. Does anybody know how long it took the human race to invent the wheel? Any guesses? 6,800 years to invent the wheel. If you count using it as a potter's wheel, it's actually about 6,500. I'm not going to split hairs. But for being used as transportation, it's 6,800 years. That's a lot of effort. Let's talk about architectures and frameworks in LabVIEW. A successful framework, do you think that's measured in the effort required? Is it measured in man hours, man months, man years, man decades? Any thoughts? Man years. It's not really hard to imagine. But let's think about that for a second. If you write a new framework every time you write a new architecture, that's a lot of time.
How many woman years is that?
I've asked the exact same question. And to that end, I'm going to go back. People don't want to pay you for work you've already done. I talked to her during this, and that was one of her key takeaways.
She paid me to say that.
So for those of us that write frameworks, it's hard to monetize a framework. I think it used to be easier, but these days, if it's not open source, people generally aren't interested in it. So they don't want to
hit by the bus problem, like companies get hit by the bus too.
Yeah.
Right.
Yeah, absolutely. So just keep in mind, people don't want to pay you for work you've already done, so trying to monetize a framework is a little bit difficult. There's also this concept of build it and they will come, and everybody's going to come use your framework, it's going to be great, everything's going to be awesome, and they might come and use your framework. But there's also the concept of build it and you own it, like an albatross around your neck, forever. Frameworks are a commitment. Think about that. So shifting gears a little bit, I'm going to quote my father here, actually. Mantra of my childhood: you don't do this, and you don't do that. And by God, when you do it, you don't get caught. So, let's talk about the things you shouldn't do and why you shouldn't do them. And we're going to talk about technical problems you will encounter. I'm going to bias this towards like a messaging framework. There are any number of problems you can hit with different kinds of frameworks. I'm most familiar with messaging frameworks. I think most of us primarily write messaging frameworks, but that's going to be my point of reference. But let's look at this as growth opportunities you will encounter when writing your own framework instead of technical problems. This is going to be a key point that I'm going to come back to later. Some of the big ones that are going to come out and bite you: lifetime management of your application, intermodule communication, error handling, and instance management. These are the 4 things that are really just going to bite you. So let's talk about them. Lifetime management. Your modules need to be shut down at some point. When you shut them down, how do you do it? And how do you do it so you don't get a deadlock? And how do you do it so that everything actually gets a shutdown signal? That's really hard. You can kill LabVIEW. That's pretty reliable. But that is an option. But it's really hard. Why do you want to subject yourself to that? It's already been done numerous times.
And developers need to know how it works if they're using it in addition.
Yeah. I think I'm going to hit on that in a little bit. Determination mechanism, let's briefly talk about what mechanisms you can use. You can use things like a sentinel value in your messaging system. You can use a dedicated communication channel for shutdown. Another thing I've seen is just throwing an error and relying on the framework to shut down because you got an error. Don't do that. Please don't do that.
The active framework does.
No, active framework doesn't terminate on an error. It sends a message to shut down.
Oh, you're right. That's very good.
I mean, you need to preserve your errors throughout, but an error itself should not. You might want to terminate on an error. Let's be clear. You might want to terminate on an error, but you don't want to rely on an error to be your termination mechanism. You don't want to at the end just say, "Okay, I'm done. Error equals true. Error code 0. Done." I've seen it done numerous times. Queued message handlers, the really simple queued message handlers you always see, the 2 parallel loops.
Oh, yeah.
How many people maybe the template does that. Yeah, but does it kill any? So does it kill it another way though? I don't remember. I used the template forever. I feel like there's also an implicit mechanism for transferring this.
Yeah.
But anyways, we're divergent. Anyways, don't do that. Intermodule communication, things you have to think about are what level of abstraction do you want for your module? What level of knowledge can they have about other modules? Can you be fully decoupled? Can your modules, some of your modules know about each other? Do you care? I have answers for that. They might not be right for every situation. How about addressing? How do you tell your message where to go? Do you have a postmaster mechanism where you have a common queue that has everything, sends it out? Do you have intelligent modules that know how to route the messages themselves? There's different options you have available to you. Among those options, you have different delivery mechanisms. Queues, user events, notifiers, self-addressed stamped envelopes. Other things you need to think about are synchronization issues. You can make all of your messages asynchronous. Pretty easy. Usually the easiest way to do it. 9 times out of 10 it's going to work for you. But at one time where you need a response or you need something synchronous, that's going to sting because you don't have it built in if you didn't think about it in advance. So that's another one of the big problems that people encounter writing on framework. The concept of needing both asynchronous and synchronous calls. Error handling, Darren will point out there are 5 different types of error handling. I'm going to focus on 2 of them, error propagation and error response. Error propagation, you need to keep a few things in mind. What modules need to know about the errors you're throwing? Does module A need to know about an error in module B? Does it care? Don't know. Does A always need to know about B? How do you route the errors and get them to the right places? How do you even know what places are the right places? Another really hard problem. How do you respond to an error? Just because you finally now know about the error, do you shut everything down? Do you go to a safe state? What do you do? Another really hard problem that has been solved by numerous frameworks. Instance management, singleton versus miniton. These are fundamental concepts that aren't easy to implement. I mean, you can implement a singleton relatively trivially, but you end up with side effects. Use existing things that do it for you.
What are
Sure. A singleton means you have a class, and you will only ever have one instance of that class. So all this data will always be consistent across everything, and you cannot have two instances. Miniton is you can have it together. Other problems you will encounter, notice I do say problems here, not growth opportunities. Ownership and support. So if you write the framework, chances are you're going to own it. What comes along with ownership? You have to worry about maintenance. Any bugs, chances are on you, or if you're lucky, your team. Maybe if you're lucky. Sometimes it's better to come to on you. The life cycle of the framework, what are its plans for the future in terms of how long it's going to last, what are its obsolescence plans, things like that. Often if you own the framework, you're responsible for that. And plans for future development. What features do you add? What bugs do you fix? Things like that. These are all things that suddenly belong to you if you write the framework in most cases. Also, if you don't invest those man or woman years up front, you get support. You're going to get support no matter what, let's be clear. But the more you invest up front, the less support you're going to have. But you have support of your framework. That's fairly obvious. Shouldn't be a surprise if the framework's broken and you need to help fix it. You also need to help your customers make extensions to the framework. When we talk about a framework isn't useful unless it's extensible, you need to be there to help them make those extensions. Finally, they're going to make those extensions, hopefully, and then there's going to be problems with them. They're going to be simple problems that have nothing to do with your framework. But because it's plugging into your framework, suddenly it's your problem, without fail. So, we've talked about a few of the problems we'll see. Let's talk about not getting caught. First thing, draw a line in the sand between your framework and their code. Make it very clear if the error is coming from your framework or if it's something they've done. This is another thing that's really hard to do right. But it's worth the effort because it makes those support calls so much simpler, or support interactions, or emails, or however you're talking to your user or whoever's consuming your framework. Really, I would rather have a trench here instead of a line in the sand. I looked for pictures of trenches, and I got onto trench warfare, and that just got really bleak really quick. So we're not going to trenches. Another key thing to keep in mind, never design a reusable API for one use case. You will inevitably bias toward that one. If you set down and write a framework for your application, chances are it's not going to be a framework. It's going to be a messaging system. Then you're going to wrap it around into something else. It's going to be a different messaging system. And maybe after you use it 12 times, it becomes a framework. But if you sat down and thought about it in advance and made these intelligent design choices from multiple implementations, you would have had a framework from the start. Support. Support's rough, but if you make it open source, more people can and probably will be willing to help out if the code is there for everyone to see. Furthermore, if you develop in front of the community, as most open source projects do, you'll get input as you go along. This input will guide your design decisions, and it's like having a million use cases if you have a million people looking at it. Suddenly you get these corner cases that you would have missed otherwise. I cannot stress enough that open source, or at least community development, is fantastic. Even if you're the only one actually doing the development, having people using it for tests to play with it. Let's be clear, I'm not saying you develop it when people use it until it's done. But if you have people looking at it as you go along and playing with it and interested in it, you're in a good spot. Documentation is almost never a bad thing. If you write bad documentation, that is a bad thing. Please don't do that. And finally, make sure your framework is final before it's released. I said develop for the community. Don't set the expectation that this work in progress is a usable thing. It's something to play with. So what is a release process? Well, a release process consists of a few things. First of all, you need tests. You need a lot of tests. You need unit tests and you need integration tests. To be clear, unit tests are for you. They help you as the developer. Integration tests are for your customer. They make sure it works when they get it and it all works cleanly together. Just a little tidbit I picked up as I went along. Also make sure you have a repeatable build process. Hit build, then go over to this directory and copy this thing over here, and then go to this directory and copy that in, and finally put the whole thing in the zip file. It's not a build process. That's a repeatable, it's a pain in the neck. That's what it is. Worth noting, ISO 9001, everyone's really heard of it. Do you know it doesn't guarantee high quality necessarily? It guarantees repeatability. It makes sure you do the same thing every time, and hopefully it's the good thing. But what it really makes very clear is you get the same thing over and over again, which is good. And finally, I was introduced to this word a couple years ago. Has anybody ever heard deployment? No. Well, as the name implies, it's terrifying. I've seen people developing in main of their source code control, sending code to customers from main. They make a bug fix, they send the code out from main, everything's done in main, there's no release branch, constantly fixing bugs as you go. It is a nightmare. Don't do it. It's tempting, sometimes you just have to get something out the door. Do everything you can to avoid deployment. They're miserable. So, let's go into a summary really quick. We're going, yeah.
Yeah, I just wanted some clarification on that. So you said doing bug fixes in the main when there's new. So what I think I'm hearing you say is don't do bug fixes while you're also doing new features and give them bug fixes with new features at the same time. Okay.
Yes. Sorry. So yeah, that code base time used to everything was done in main. So there was no concept of a branch. Everything was in a big monolith. So when I say main, just think in the code base that you're deploying from and developing and doing all of this stuff.
Okay, and so what I think I'm hearing you say is it would actually be okay if we stopped active development of new features.
Yeah.
And we said we're only doing bug fixes. And then at some point in the future, we do development, right?
Yeah. I'm fine with that.
Okay, but
Yeah.
but never mix new features with bug fixes and try to do kind of concurrently
Yeah.
and think that they're going to get something that doesn't have bugs in it.
Exactly.
Yeah.
And also, deploying mostly working features because they need the feature and they're going to put it in production, but it's mostly working.
Right.
So let's just give it to them and see if it works and then fix the bugs. I've seen it. It scares me. Yeah, customer testing, yeah.
I mean, that's how games and web browsers work, right? They just throw it out there and have people test it.
Windows 10 monthly updates?
Any other question?
Are you still, all we can do is not to get caught section?
This is all in don't get caught.
This is all. I have other ideas.
Yeah.
I don't know if you're gonna cover them.
Nope, I'm gonna throw a summary in here, but this is most of the meeting.
Okay, one thing I would say is provide templates as much as possible, working templates.
Yep.
Templates so that they actually run, they're not broken, and and very well documented say, hey, this is where you put in your business logic to run. And also have an example framework that completely runs without breaking, so that someone can see it and have confidence that they can use it.
Yeah. So to repeat back what you said so everyone can hear, I don't know if it made it back to the room. Basically, you want to have good development tools and templates for your end users to consume. And I'm sorry, you said you also wanted to have
A running example of the framework.
yes, a running example of the framework, so that they can just sit down and say, hit run, okay, this is how it works, cool, now let's dive in and make my, correct. Yes, I wholeheartedly agree with that. So let's go into the summary, unless anyone else has any other tips they want to throw out. So, yeah.
So, right when you were talking about nobody wants to pay for what you've already done, and then you follow a slide with this, don't tell anybody, don't ask, don't tell her, or something, you would quote from your dad, don't do this, don't do that.
And when you do it, don't get caught.
Well, so, customers will pay for frameworks if you don't tell them they're paying for a framework.
Good.
And so you can sell them the value that the framework is bringing to your application development if you sell them a working application.
Yes.
They don't need to know that there's a framework under there, but they're essentially paying for the framework. You're just not line iteming, right?
I think the key difference is they're paying for an architecture.
Well, they're paying for a solution to their business problem, which
Yes.
is an application that meets their requirements.
Right.
Right.
So you're using a framework.
Yeah.
I think that's the point I'm trying to make is use an existing framework.
Yeah, but don't.
Maybe you developed it previously, that's fine.
But you're probably not going to make money by selling your framework on your website.
Right,
Yeah.
exactly. And if you try to give a customer a framework that's non-standard and say, oh, just plug this in here and it's going to be fine. It's not going to end well. Most times, it's not. They're not going to be happy. Anything else? All right, so we're talking about how long trips are going to go. Yeah.
I would also add, along with your unit testing, and do burden testing. If you can. You can do a lot of burden testing to make sure that there might be some intermittent problems or whatever you're encountering, that you're going to encounter. By doing repeated burden testing, you might be able to actually find it.
In short, test, test, test. We're done testing right before tests and run them some more. That is
Eventually, you should.
not to do it right.
But you don't have to stop testing it.
We'll get there. We'll get there.
Yeah, so much.
We'll get there. We'll get there. So I said, don't reinvent the wheel. There are times you need a maglev train. So you're not reinventing the wheel. You're doing something different. Any ideas for grains how long it took to invent maglev trains? 12,000 years. Random tidbit. Went along with the wheel. So anyway, can anybody think of unique situations where it does make sense to write your own framework? We talked about all the things that are going to bite you. Some of the reasons you shouldn't. Why should you? Any thoughts?
Sure, there's not an outdoor example that, for example, provides great visibility into all the messaging states that you follow. It doesn't necessarily tell you all the execution paths that you're taking. So, for example, like that, you can't find something like that. And you say, hey, only way I can get that is by
So I will challenge you. Do you have to have a new framework? Or can you extend an existing framework to expose that functionality? And have most of the hard problems solved for you?
Well,
It depends on what framework you start from.
okay.
It's all gray areas. So I'm not saying you can or can't, I'm just saying, think about that before you do it.
Well, I've seen several examples and I'm like, well, this isn't quite, this is close.
Yeah,
Hey,
you might need to write your own because you don't have one that fits your needs. It's entirely possible, but try like heck to avoid it. Yeah.
The licensing for the frameworks may be such that the proprietary information you have that you need to deal with and the licensing structure for the framework are incompatible.
Yes. One of the key points I was going to make, I do have some answers here. One of the points I was going to make was open source, for example, sometimes is a no-go. You can't use it for some contract, it's just the way it is. You might have to roll your own.
oh yeah, and then is you create your own, and you can get visibility into the details of what cause of
That's true. So a sufficiently developed framework mitigates that problem. Because the errors aren't coming from the framework, they're coming from your modules. And if you test your modules and it's a testable framework, the framework provides tests to test your modules, then that gets you back to not needing to write your own in some sense. Another one nobody's mentioned yet, performance. Off-the-shelf frameworks are not optimized for your use case. They're not. If you need flat-out performance with the best memory usage or the fastest execution speed or whatever you need, you're probably going to write your own. It's a handbook, yeah.
Another challenge is you have a simpler project that doesn't require the whole active framework. That you get, I had a coworker who designed this totally abstract class method. And it was so abstract, it was, in my mind, from my point of view, useless. Because I didn't understand it. And so there's the complexity that it's overkill. You don't use test stand when a simple sequencer will work. If you have a simple data acquisition system, you probably don't need to. You may bring in the message handler that's used in the active framework, and you may kind of pick what you need, because the full active framework is just totally overkill, and you're going to spend a lot of time commenting out stuff you don't need.
But I think you still have my key point is reuse everything you can. Even if you're not using the entire framework, you said pull pieces from the active framework, if that makes sense, yes.
But then and then on the other side is I developed this really cool application. I gave it to another coworker to use, and he spent more time picking out what I thought was useful that wasn't that useful for his application, and so it wasn't a totally efficient use of the code. We were trying to use code reuse, and I had this really cool architecture for the sequencer and spend more time hacking it.
Yeah. So, yeah, go ahead, sorry.
I was just going to say this isn't necessarily a business case, but there's definitely an educational case in going through that process of doing that, because you learn a lot. I mean, a lot of those things that you list, you don't really get an appreciation for how hard they actually are until you try to do them.
You're cutting to my chase.
Sorry.
So what I was about to say was, I have an admission to make. I got this session approved. I went to another company, and I basically rewrote a framework. Now, I would do it again. And I will tell you why. I came into a new company, new code base, a lot of applications that are based on very similar things. They didn't have a super solid framework. They had similar messaging architectures that they used from different application to application. And they sat me down and said, hey, seem to know your stuff. Let's have you take a look at it and make some recommendations on what you change. So I did. I sat down, I tore it apart, kind of put it back together a little bit again. I'm using this modified framework for my next application. And it was a great learning opportunity to learn their code base. Not only what goes into a framework, but to learn their code base. Because if I came in and said, okay guys, this is cool and all, but let's just use active framework, or let's just use DQMH. It might work well. I mean, maybe everybody get on board and we have all these new applications, this new messaging framework, and everything will be great. But as soon as we have to go back and touch that old code, you're out of luck. And chances are you're going to go back and touch that old code. So if you're coming into a new situation, it does make sense to at least learn their framework, often by rewriting it in a better manner, depending on the state of their framework. And then, after you know it, convince them to do something else. I'm still working on that.
So I think one of the answers to the question why you do not rewrite the form would be really, so I was talking about this morning, maintainability. What it is that you're going to achieve with a specific solution that you give to your customer. And it could be, oh, those people are CLA, type of people working in this company, so I don't want them an anchor framework. It's over.
Right, and that's another reason I haven't really pushed to settle on an established framework at my new company, because we have a lot of people with varying skill levels, and I'm honestly not sure what to recommend to them as a universal framework that everyone can use. I have my preferences. I think some things are easier than other things to pick up on. Other people disagree with me. So I can't tell you what framework to use. I can't even tell my employer what framework I think they should use. But try to use something existing. Try to figure it out, because you're going to waste a lot of time if you don't. So just to recap, an architecture is made using frameworks. I just want to clarify, beat in this point. Build your own architectures. Make architectures all day, every day. Don't build frameworks. Everyone, a lot of people recognize the Chrysler Building, the Empire State Building, all these great works of architecture. How many people recognize an Otis elevator when they see it? You want to be...
I'm not sure I'm going to that state, because I see a lot of time, I will create the element diagram for somebody in a use case, the solution for the customer. And then I'm going to think, okay, which framework will be the best for them to use? Okay, so my architecture doesn't care about the framework so much. I have, my component, my classes, and then now which framework do I use? Can we do that, the framework? Can we do SMO? Can we do DTMH or whatever? So sometimes the architecture it may be tied to the framework, but sometimes it doesn't need to be.
So I think the point I was trying to make was not the architecture, the frameworks define your architecture. It was very much the opposite. You have an architecture, and you could probably use several frameworks to fulfill the needs of that architecture. You shouldn't design your architecture around a particular framework in many cases. Now, once you get into the low-level actually implementing things, you're going to have to settle on a framework. But when you're building your architecture in general broad forms, often you don't even want to settle on a framework that you're using. Maybe you use multiple frameworks in the same application. I mean,
A framework by definition is not problem or domain specific. Right?
yes,
If it is, it's not a framework.
yes, I agree. Mostly agree.
Okay, maybe there's some special frameworks for solving
It's very overloaded.
many different problems in a domain, but
Yeah.
the frameworks we're talking about.
Yes.
Active framework, it doesn't care.
Right.
Extension.
Yep. So, in conclusion, write your own framework and then throw it away. Because it's a great learning experience, you did a lot of cool stuff, and now you can actually do something productive. That's all I got, so thanks, and questions?
Yes.
No? Okay. Oh, yeah.
I wanted to make a comment. So with creating kind of reusable APIs too early, I've heard those called obstruction layers.
Yes, yes, I like that.
If you've only got one use case, and you're like, I'm going to create my abstract class and like one class in my application that inherits from it, because someday somebody might like want to inherit from it and plug into it.
That's
Try to
what I
oversee
like.
every use case.
Yeah.
Okay. Thanks, guys.